I'm just going to walk through these 5 problems quickly. That way, if you're struggling, you can kind of follow along and hopefully it will help you complete it. So the first thing we have to do is balance the equation. So I have 2 hydrogens, 2 oxygens, and 1 oxygen. So I have to multiply this by 2 to get it to equal. And that also changes my hydrogens to 4. So now I have to multiply this hydrogen by 2. And now everything equals, so that leaves a 1 there in the middle. So for the question, it says I'm starting with 0.408 moles of water, and I'm looking for moles of hydrogen. So I'm just going to use my big numbers. So I have 2 hydrogen. 2 hydrogen for every 2 water. So I'm going to put water on the bottom because that's what I have. Hydrogen on the top. These cancel out, so I'm left with not water, left with hydrogen. 0.408 hydrogen, right? Because my waters cancel. I'm left with this and this. So let's look at the next one. We're going to do the same thing. We're going to balance. So sodium, I have 1 and 1. Chlorine, I have 2 and 1. So that means I have to multiply this by 2. That also changes my sodium. So I have to multiply this sodium by 2. And now everything is balanced. There's my invisible 1. So it tells me I'm starting with 7.230 moles of sodium. So I'm going to look at my balanced equation. I have 2 sodium. Remember, I'm putting that on the bottom so that it cancels out. And then I'm looking for NaCl, which is also 2. So those 2's are going to cancel out. I'm left with this and this. Okay, let's look at the next one. So we're going to balance, or actually this is the same equation as the one above, so we can just use that same one. So let's see what I'm starting with. 14.59 grams of CO2. So remember, the trick here is that I cannot use my ratios, my big numbers. If I'm in grams, I have to be in moles. So the first thing we're going to do is convert into moles. And since this is diatomic chlorine, I know I have to add 2 chlorines up together. So I added a 35.45 plus 35.45. And that is equal to 1 mole of chlorine. So now I can convert into my moles. So I have 0.206 moles of chlorine. Okay, so now I can use my ratio. So I'm starting with chlorine. So my equation says I only have 1 of those. I'm looking for sodium chloride. It says I have 2 of those. So now my chlorines are canceled, right? I can multiply the top. So I'm left with 0.412 moles of NaCl. Okay, so remember, I'm always using my big numbers here to help me convert from what I have to what I want. Okay, and now let's look at this next one. This should really be number 4. It just kind of restarted numbering. So let's balance our equation. So remember, we always want to save what we have by itself until last. So I'm going to save copper. And then I typically save my hydrogens for last just because I like to. So I'm going to start with chlorine. So I only have 1 over there, 2 over there. That means I have to multiply by 2. Okay, so now let's look at hydrogens because I'm going to save my copper. So this 2, right, applies to this whole thing. So I have 2 hydrogens. See, there we go. It worked out nice. It's all balanced. And then for copper, we just have 1. And then for copper, we just have 1. So these are all invisible ones because everything matches up. So now let's look at the question. It says I have 6.70 moles of HCl. Okay, so I'm in moles, so that means I can use my big numbers. So I have 2, and I'm looking for hydrogen. So hydrogen only has 1. Okay, so this is going to tell me my number of moles. So remember, the HCl's are gone, so I'm just going to do the 6.7 divided by the bottom. So I have 3.35 moles of hydrogen, but the question is asking for grams. So I have to go one more step and convert my moles to grams. So I found my hydrogen mass was 1.01, but since hydrogen is diatomic, H2, I'm going to add 2 hydrogens up together. And then when I multiply across the top, I get 6.77 grams of hydrogen. All right, let's go ahead and do this last one. Again, this should really be question number 5. So I'm going to save my hydrogens, oxygens to last. So let's start with carbon. I just have 1 and 1, so that balances out. I'm going to save oxygens for last because here I have kind of an oxygen by itself. So 4 H's over here, but I only have 2. So how am I going to get 4? I have to multiply by 2. Okay, so now I can count my oxygens. I have 2 on this side. On this side, I have these 2, but then I also have 2 times 1. So 4 total. So that means I have to multiply that by 2 to get it to equal 4. So let me erase some of these random arrows so it doesn't get confusing. Fill in my 1s. And now I'm ready for the question. So it says I'm starting with this right here. So 27.62 grams of CH4. And again, I cannot use my big numbers until I'm in moles, right? Because these big numbers are talking about moles. So that means I have to use my molar mass to convert into moles of CH4. So I'm going to add up 1 carbon and 4 hydrogens, and I end up with 16.05 grams. So if I divide, right, multiply the top, divide by the bottom, 7.62. I get 1.72, whoops, this is moles, because my grams have canceled with CH4. Right, my grams cancel, so I'm left with moles. So now that I have moles, now I can use my big numbers to convert. So CH4, here it is. I just have 1. And then I'm looking for CO2. So here it is. There's just 1. So this is just my CH4s cancel out. So now I'm talking about CO2. So I have 1.72 moles. The question though asked me for grams. So my last step is going to use my molar mass. So I'm going to add up 1 carbon and 2 oxygens to get my molar mass. And then multiply the top, divide by the bottom, and I get 75.7 grams of CO2. So hopefully that helped you work through some of the problems. The biggest thing, you're just, your goal, right, is to get from your moles, what you have, to the moles of what you want, right? So this is what we have and this is what we want. The way that we get there is we're always going to just use the ratio or the big, I'll put big numbers, right, of our equation. Okay, that's our mole ratio. That's telling us what we need compared to what we can make. And then the only other thing you have to do is sometimes, right, if it starts with grams, you just have to use your periodic table to convert to moles. And then sometimes if we want grams as our final answer, then you just have to use your periodic table to convert into grams, right? But our biggest thing is this right here. We're just using our balanced equation to go from what we have to what we want.